Now we come to purification of colloidal sols. If a sol contains impurities of suspension type, that is insoluble, then such a sol is filtered through a filter paper, where only colloidal solution will pass through the filter paper, leaving the insoluble impurities on the filter paper itself. But if sol contains impurities of soluble nature, then dialysis is carried out. Dialysis. In this method, such a sol is allowed to be filtered through animal membrane or parchment paper or cellophane tap or cellophane membrane, where sol cannot pass through such membranes, but soluble impurities, that is colloidal particles, will pass through. As shown in the following figure, a bag made up of such a membrane containing the impure colloidal solution is suspended in fresh water. The crystalloidal impurities pass out, leaving behind the sol. If the impurities are of electrolytic in nature, then separation or purification can be made fast by applying electric potential through two electrodes. This method is then known as electrodialysis. Besides dialysis or electrodialysis, some methods like ultrafiltration and ultracentrifugation are also used. In the former method, filter papers of special grades called ultrafilters are used, which allow crystalloidal impurities to pass, but not the sol. While in the latter method, impure sol is taken in a tube which is placed in an ultracentrifuge on the rotation of the tube at high speed. The colloidal particles settle down at the bottom of the tube and impurities remain in the solution. Thus the dispersed phase is separated and then it is mixed with appropriate dispersion medium to give back the pure colloidal solution. Properties of colloidal solutions, that is sols. Some of the important properties of colloidal solutions can be listed as: number 1, colligative; number 2, optical; 3, mechanical; 4th, electrical; and 5th, chemical. Let us have a brief discussion of these one by one. Number 1, colligative properties. Colloidal sols show all the colligative properties. For example, osmotic pressure, lowering in vapor pressure, elevation of boiling point, and depression in freezing point. But as compared to a true solution, the number of particles in a sol will be less. Hence, experimental value of any colligative property for a sol will be less or very small. Number 2, optical properties. Tyndall effect. When a strong beam of light is passed through a colloidal sol placed in a dark place, the path of the beam gets illuminated. This phenomena was first of all observed by Tyndall, hence known as Tyndall effect. This is due to scattering of light by colloidal particles. Remember, neither solute particles in a true solution nor the insoluble particles in a suspension can show this effect, because scattering of light is done by particles of colloidal dimension. The illuminated path of the beam is called Tyndall cone. It is a matter of common experience that this phenomena is also noticed when a beam of sunlight enters a dark room through a slit in the window or door. This is due to scattering of light by dust particles present in the air. Number 3, mechanical properties. Brownian movement. When a soul is seen under an ultra microscope, the colloidal particles are seen to be in constant zigzag motion as shown below. This was first of all observed by Robert Brown for pollen grains placed in water, hence the name. Thus, colloidal particles in a soul are not at rest, but in a state of continuous zigzag motion.